All right, let's do this next problem. Section 5.5, we use the substitution method, problem number 55. This is a definite integral. Now, what I'm looking for is a composition of functions, which I think I see here. The inside function will be u equals 1 plus 7x. Take the derivative, and I find that's 7. 1 plus 7x, the derivative of 7, dx. And what I do is I divide both sides by a constant, not by anything that has x, but it's just divided by 7. And I see that literally, going back up here, that according to the substitution, dx is 1/7 du. Now I'm going to do another little thing here, is I'm going to change the bounds. Well, what do I mean by that? Well, keep in mind that these bounds are the values where we start and finish x. But I'm going to substitute, and the whole integral will involve u. So I want to have bounds that are the start and end of u for the u values. When x equals 0, u equals, well, hold on, u is a function of x. U equals 1 plus 7x. U is a function of x. So u is going to be 1 plus 7 times 0, which is 1. When x is equal to 1, now let's see what I'm doing is I'm just picking up these bounds right here, 0 and 1. That's where I'm getting these numbers. When x is equal to 1, u is equal to 1 plus 7 times 1, which is 8. So now I have new bounds that I'm going to work with when I write an integral involving u. So everything's all good to go. This whole integral is equal to integral not 0 to 1, 1 to 8. And I can even emphasize by writing u equals 1 to u equals 8. Usually I don't do that, but I could do that. Cube root of u, because u is 1 plus 7x. Then 1/7 to u. All right, now let's rewrite this in a form that will be easy for me to integrate, so and find the antiderivative. Let's write this as 1 to 8, u to 1/3 du, and I'll just put 1/7 here. Now when I find the antiderivative, I have u to the 1/3, I add 1 to 1/3. That's 1/3 plus 3/3. That makes u to the 4/3 power. And then I'll divide by 4/3. And I evaluate from 1 to 8. So this is going to equal 1/7 times the reciprocal 4/3, which is 3/4. And then what is u to the 4/3? It's u to the 1/3, which is the cube root of 3 of u, and then we raise that to the 4th power. Okay, again, u to the 4/3 is the third root of u raised to the 4th power. It's also u to the 4th power than third root, but I think it's easier to take the third root first. Let's multiply this. 3 times 1 is 3, 7 times 4 is 28. And then I'll have the third root of 4 to the 4th power minus the third root of 1 to the 4th power. So that's, I didn't really leave enough space for myself. Let me just move this down. Okay. That's equal to 3 over 28. The third, oh, okay. Everything looks good, except I made a mistake that made the whole thing confusing. I didn't put the right bound in. Here's 8, right? Here's 1. So 1 goes in and 8 goes in. So everybody, I'm sorry about that. So, okay, so it's 1 to 8. Those are the numbers I put in there, 1 and 8. All right, the third root of 8 is 2, and I raise that to the 4th power. Then the third root of 1 is 1 raised to the 4th power, and that's 1. So this is 3 over 28. 16 minus 1. 16 minus 1 is 15. 15 times 3 is 45. And let me zoom out and say, I think that finishes the video. Does anybody have any questions on that problem? Any heads up that the problems that I made a mistake?
How do you know when to divide by like 1/7 du equals dx? Like, how do you know when to do that?
I always do it if I have a constant, like 7 dx, 5 dx, 9 dx, any of the constants, I just divide it. I just do it automatically.
Oh, so we didn't do it last time because it was e to the x.
Yeah, if it's a function of x, I don't do it. Like I don't, what I really don't want to do, I mean, hypothetically, suppose I had du is equal to like 7x squared dx, hypothetically. I will still only divide the 7. I don't divide the x squared because you're not supposed to mix the x's and the u's together. So this is hypothetical. I'm going to erase it, but don't only divide by numbers, but not by the variable x, by any variables.
Thank you.
Yeah, you're welcome. Okay, so we'll finish up there.